So suppose a0 is 0, a1 is 2, and an is negative 4 an minus 1 plus 5 an minus 2 plus n minus 1 times negative 1 to the n for all n at least 2. Okay, so a little bit, I mean, most of this is kind of similar to what we, some constant times an minus 1, something times an minus 2. This is perhaps a little bit more complicated of a function than what we had before. So anyway, it's just another example. Okay, so what should I do first? Well, first of all, I've already done the first thing. I wrote down my recurrence. What should I do with it? So, and I've also defined f of x to be sum n equals 0 to infinity of an x to the n. So yeah, what should I do? Right. So I'm going to multiply everything by x to the n. X to the n an equals negative 4 an minus 1 x to the n plus 5 an minus 2 x to the n plus n minus 1 negative 1 to the n x to the n. Yeah, so that's perhaps skipping a step. So first I need to make a sum, but anyway, so this was valid for n at least 2. So what I'm going to do is I'm going to sum this up over all n at least 2, because because I can't do 1 or 0, but I can do everything at least 2. So I sum it all up, which is basically the same thing I had before, except I've got some things. So n equals 2 to infinity, an minus 1, x to the n. And then, totally. So what was said in the chat, that's our next step, is we want to kind of make these things into things that are like f of x. So first of all, what should I do with that one? And it's actually kind of the same answer as last time, right? This one here is basically f of x, except it's missing 2 of the terms, right? It's just f of x minus a0 minus a1x. What should I do with that one and that one? So, well, I've still got a 4, right? So yeah, take out an x. And once you do that, if you kind of think about shifting the thingy, the index, you can think of it starting at 1, and then all you're missing is the a0 term. So you've got all of f of x except for the n equals 0 term, totally. So then this one I'll pull out an x squared, and then if you think about changing the index, you just get f of x. Oh dear, what do I do with this one? Oh, sorry, was this should have been, let me go back to the previous slide. Is that an n? Okay, it is an n. Okay, yeah. So maybe I can pull out an x squared, just because I like the index to start at 0. I don't know. You don't have to do that. But if I do that, so I believe what I get here is n plus 1. I can leave that as negative. Okay, maybe I'll do this a bit slower. So sorry. I'm doing a lot of algebra in my head, but I should be telling you what I'm doing. Okay, so let's do this. Or maybe let's see if I've got it on the next slide anyway. Okay, let's suppose I just keep this sum as it is for now, and we'll simplify it in a second. But this is n equals 2 to infinity and whatever it is. So I mean, you always have an option of which order to do things. So let's leave this one for now. Let's solve for f of x, and then we'll play with that thing. So at this point, if I want to solve for f of x, I need to. So okay, in theory, I could have if I was asking for a general solution, then I can't plug in a0 and a1. But here I was asking for a specific solution where a0 is 0, and a1 is 2. So I'll plug those in. So I can put in a 0 here. So that's 0, that's 2, a1 is 2, a0 is 0. And then I can, okay. But anyway, so if I take the things involving f of x to one side, I get f of x plus 4x minus 5x squared, right? So that's, if I bring all the things involving f of x, I have f of x times 1 plus 4x minus 5x equals whatever else is left over. So if you take my word for it, this is the stuff that's left over. And then what I'm going to do is take this thing that's multiplying f of x and divide by it so that I can get f of x by itself. So we're just solving for f of x. Okay, and this is what we get. And like I said, this one we can say is just 0. That's 2, I think. And then that was A0 is 0. So you can plug those in if you want. And this thing factors, luckily, into 5x plus 1 and 1 minus x. Now I'm going to deal with this. Okay. So suppose I take this thing and I re-index so that I start at 0. Okay, so if you think about what happens, so if I plug in n equals 2 here, I get, so this becomes a 1. So when I plug in n equals 0 here, it should be a 1. So that means it should be n plus 1 because it's 0 plus 1, right? If I plug in 2 here, I get a 2 here. So these exponents, you can write them as n plus 2. So if you think about how you can do this with a substitution and whatever, but yeah, this is kind of how the reindexing goes. If I pull out an x squared, and I kind of recognize that negative 1 to the n plus 2 is the same as negative 1 to the n, because negative 1 squared is just 1. I get n plus 1, negative 1 to the n, x to the n. So what do I have here? So this is something we can recognize. It's slightly different than the usual thing because it has this negative 1 to the n, but we've seen this before today, basically. So what can I write here? So I've got my x squared, which is there, and what's the rest of it? So I'm asking a lot of questions today, I realize, but yeah, totally. So, right, because basically this is the same, we've seen this one today, and that is equal to 1 over 1 plus x squared, right? And this thing is basically the same, I've kind of messed this up. 1 minus x squared, because it's the derivative of 1 over 1 minus x. This is basically the same thing, except there's a minus 1 here. So I should plug in, for x, I should plug in a negative x. So it's 1 plus x squared. So now I've actually got a formula for f of x, because I can just write a nice closed formula, because I can I plug in a0 is 0 and a1 is 2 into that thing. And I plug in this for my infinite sum. And so I've got f of x is 5x plus 1 on the bottom, 1 minus x on the bottom. And then if I kind of put everything together, right, I've got this 2x here. If I want to combine this with this fraction, I have to multiply by a 1 plus x squared. So anyway, at the end of the day, you can do the algebra, but it gives you this, which looks like bad news because, okay, you can do this because you know how to do partial fractions in general, but on the bottom, it's a degree 4 polynomial. I mean, you can do it, right? But it kind of sucks, right? But you can write this as a over 5x plus 1 plus b over 1 minus x plus c over 1 plus x plus d over 1 plus x squared. Oh, sorry, that should be a d. Sorry, and that should be 1 plus x all squared. Right, that's how partial fractions works. And yeah, so so I was going to ask you yet another question of what to put on the bottoms of these things, but yeah. So this is how partial fractions works, right? If you have something showing up once, you just put it like this, a over that thing, b over that thing. This one has a square, so you have to do x plus 1 or 1 plus x, it doesn't matter. And yeah, we can do this. We have the ability to do this by hand, but yeah, I would perhaps, if you are crunched for time, doing these things, I guess on an assignment, I do want you to show your work. So please do on an assignment. Unfortunately, I would like you to do all the calculations here. In some cases, and also on a test, I guess, I want to see the work. But if you're doing this in your life, in practice, just use a computer. So I got Wolfram Alpha to do this. But if you do want to get full marks, you do have to do these things by hand. The good thing is that I'll probably never give you something this complicated to do by hand, right? It would be kind of evil for me to do that, especially on a test. But yeah, so for the purposes of this lecture, I got the computer to do this. Remember there was an x here, so don't forget this x because that'll mess up your whole solution. And then so I got the computer to get this, And so what you end up with is A is 45 over 32, B is 3 over 8, C is 3 over 32, and D is 1 over 8, whatever. Okay, so what's our solution then? So let's start with the things that are easiest first. So what should I put here? So I'm trying to deal with this term. So this is the easiest one because it's just a 1 over 1 minus x, right? So it's just x to the n, right? Now let's deal with this term. That's kind of the next easiest. So of course, x plus 1 is the same as 1 plus x, right? So if you think about a substitution like x equals negative x, and you think back to this example, right? So this is just negative 1 to the n, x to the n. I've got this one, which is, you can get from knowing how to do this, right? And knowing that this is the derivative of that. Like there's this chain of kind of things we know. But yeah, so this is just going to be n plus 1, negative 1 to the n, x to the n. And then this one, it perhaps looks like something you don't know how to do, but you do know how to do this. If I have 1 over, so I'm going to write this backwards. I'll write 1 plus 5x. And obviously I don't care about the 45 and the 32. Those are just sitting here. This is equal to 1 over 5. So I'm going to pull out a 5. Oh, no, sorry, I don't need to do that. Why would I do that? This doesn't look like something you don't know how to do. It looks totally like the right thing. Because this is just 1 plus 5x. So it's just 5 to the n, x to the n, by doing a simple substitution. I was thinking of 5 minus x, or 5 plus x, in which case I would want to write that as 1 over 5, 1 plus x over 5. But yeah, that's not what this is. And that's the end of it. Oh, yeah, thanks. I feel like I make so many mistakes that that unfortunately, if you make these mistakes, you may lose marks. But yeah, it's tricky. You got to check your algebra on these things, and they're quite complicated. It's easy to make small mistakes, but yeah, I'm telling the marker to be quite generous with the marks in terms of if you make small mistakes, but we'll see. Right. So what's the coefficient of x to the n? And here's the thing. Do not forget this x here. So there's this x that we pulled out a long time ago. And that changes things, right? So if I kind of pull this, if I think about putting this x inside, it changes all of these exponents to n plus 1, right? Those all become n plus 1. And then if you think about shifting the index, it's kind of like taking these exponents, making them n minus 1. Right, so the coefficient here of x to the 0, so right, is 0 because of this x. So a0 is 0, but that's actually, we already knew that. That was our initial condition, so that's kind of good. And for n at least 1, your coefficient is going to be kind of this thing, but with an n minus 1 because of this x times, yeah, anyway. So it's, if you do the algebra, you can work out that we end up with this solution that an is 45 over 32, negative 5 to the n minus 1, where that n minus 1 comes from kind of the fact that there's this x outside before, plus 3/8 plus 3 over 32, negative 1 to the n minus 1, plus negative 1 to the n minus 1 over 8 times the n, where that comes from this last term here. And again, you have to, when you pull in the x, you have to change the indices and stuff. And that's why this is, on the next slide, it's an n instead of an n plus 1 here. Now, like I said, there's a lot of places to mess this up. If you were afraid that you've messed this up and you wanted to check your answer, you can always just plug in a few values, right? So if I plug in, remember we were given that a1 is 2, I think, right? So if I plug in a 1 here to all these n's, you should get 2. Do you get 2? I have no idea. You get 45 over 32 from the first term times negative 5 to the 0, so that's fine. So here we're plugging in n equals 1, plus 3/8 plus 3 over 32, again, negative 1 to the 0, plus negative 1 to the 0, so 1 over 8, and then times n, which is 1, and hopefully it's equal to 2.